or good afternoon. It depends on you play this clip. My name is Bùi Quang Thành from Viet Nam University of Science, Viet Nam National University, Hanoi. So first of all, I would thank Professor Jimmy Chow and his colleagues to invite me to International Smart City e-Forum that virtually organized in Feng University, Taiwan. So the topic of my talk is Earth observation in Vietnam with the challenges and opportunities together with my colleague from Milan. The agenda of my talk is remote sensing in supporting decision making. I talk about natural hazards, application and urban planning, urban management, land coverage classification with remote sensing data, and remote sensing in Vietnam in general, and remote sensing education in Vietnam. As you can see that remote sensing is applicable in many fields. Remote sensing technology to support sustainable urban development, and it meets ever-increasing demand for city-based populations. Earth observation to support natural hazards analysis, urban zoning, population density mapping, and planning the city of future and traffic management. So I'm currently also involved in the project with traffic management. So hopefully that I can show you the result in the near future. So as you can see that satellite can be downloaded for free from many sources. Satellite data can be applied for monitoring on any natural hazards across the globe, and therefore a crucial component of all phases of disaster management cycle and urban planning. More and more satellite imagery is available for free, and the images are continuously growing, so they are great treasure, but it's still underexploited. So you can see on the screen of several slides that are several images I downloaded from the internet about the volume of Landsat data and the volume of Sentinel data from Copernicus program, and the number of downloads from Landsat. That's the data from USGS. Okay, remote sensing is applicable in many fields. You can see here on the screen that with air pollution, biodiversity, urbanization, climate and greenhouse gas emission, food security, ocean research, and ocean technology. That's a global issue, but this issue also critical also in Vietnam. So I'm going to talk a little bit about natural hazards. That's what I am currently working on. It focuses on landslide, flood susceptibility, early warning system, and urban management at land use and coverage classification, and some application with energy. That's detection, roof that is attachable to the solar panel to produce energy. So you can see on the screen that the two landslide, two images that I downloaded from the internet. That's landslide on the left and flood on the right. That's two common natural hazards in the mountains of Vietnam. So actually, you know that there are many urban areas which are located in the downstream of the river, particularly in the central province of Vietnam. So to maintain a sustainable city, should the certain care about the natural hazards should be mentioned. That means we should be aware of the natural hazard in the downstream in order to prevent its consequences in the downstream, especially in the urban area. So how to do with we have satellite data, we have the big spatial data. How to analyze this? So we only talk we talk about machine learning, we talk about deep learning. So that's a two common technique that we are normally used for processing big spatial data. So that is a slide downloaded from the internet. So you can see that is a classification of the machine learning algorithm that involves the deep learning and similar network, clustering, density, variations, a lot, and something and some more. That's because the algorithm has been developed currently, and there are more opportunities that we can use this algorithm for application in natural hazards and urban management. So I'm going to show you some results from our current project. So this is the application of the paper that's concerned about the landslide susceptibility mapping in northwestern part of Vietnam. So actually we collect the historical landslide from the survey and from manual interpretation, aerial photo, and high resolution satellite data to detect areas have a satellite and have a landslide in the past. And after that, we build a machine learning model. In this case, we build a CNN in combination with more flame optimization algorithm to build the landslide susceptibility map in the study area with the use of relevant input data. So you can see here the final result, and with the red area that's very high susceptibility to landslide. So the area is going to be so dangerous, so it should be attend more attention for the management or mitigation of hazards. So this is another application, another paper concerning the classification of urban land cover in Hanoi. So we developed a model with the combination of well-optimized algorithm and adaptive neural fuzzy inference system, or ANFIS, for the detection and for the detection of land cover pattern in Hanoi, and we use spot 6 images for the detection of this thing, spot 7, sorry. And this is the result. This is the segmentation result, and this is the classification result. And another application, another paper concerning the use of another optimization. Here we use social spider optimization algorithm in combination with fuzzy semi clustering for clustering the classes, and for the classification of class in Hanoi. Here in this paper we use 3 datasets that from Landsat, Sentinel, and Spot 7, and see the final result. That you can see the differences between the result from Spot, Sentinel, and Landsat because of the different resolution. Okay, the study for land use and land cover change has been extended with the project led by my colleague from NASA, and I'm happy to be a collaborator of this project together with several collaborators across the world, from US, from Europe, and from Asia, and a study for the land use data change and impact in Vietnam and in Southeast Asia countries. So hopefully we can share this result in the near future. Okay, we have a big spatial data. How we process this? Yes, we have several platforms for the processing big spatial data. We mentioned about Amazon platform. We mentioned about Google Earth Engine from also Bentley solution, or from S-Rise. Okay, we have from my university have a copyright. Free copyright for education from S-Rise company. Thank you for this company for supporting us. And something more we mentioned here, that's the Open Data Group. So Open Data Group is a new initiative for hosting the data and provide some ready analysis model that everyone can have access to that, download the data, and process the data. And Open Data Group has been installed in Vietnam National Space Center. You can go to the datagroup.vn for more information about this initiative that has been initialized in Vietnam National Space Center. So I'm going to go a little bit more about detail about a module we have developed for that's integratable to Open Data Group, that's called Automate Cloud Segmentation Method for Hyperspectral Remote Sensing Image using Deep Learning Algorithm, integratable with the Open Data Group environment. So as you can see, that's the percent of cloud and its coverage level in image could affect integrity and the value of that image in remote sensing applications that rely on optical satellite data. That's cloud covering is the most critical issue with optical data. So we need to remove the cloud, need to segment the cloud, feed out the cloud, and we can do that. Here in this study, you Landsat 8 image. So in combination with our Open Data Group, we produce an ultimate cloud segmentation methods, especially applied for multi-scale Landsat 8 image in Open Data Group environment built on deep learning algorithms. So here's some slides. I'm gonna skip it. This is some introduction about how CNN look like and from the input to the result. And this is another example about UNet. That is a CNN model inspired by a UNet architecture, which was originally created for medical segmentation, but it can be also applicable for with remote sensing data. That means start from input data going to the convolutional layer, and we go deeper and go up as a deconvolutional layer and produce the output. The output have the same size as the input. That's the classifier map. So for this application, we forward a blended 8 that has red, green, blue, and near infrared, and the output going to be 2 pixels, 1 for cloud and 0 for non-cloud, as you can see on the screen. And we design the size of the patches at 384. 384. So why you choose this size? It's because on the computing capability for our workstation. Yeah, so the two phase, that encoding phase and decoding phase that you have resolved. This is cloud filtering and cloud area from the satellite unit. In order to train the data, we need in order to train the model, we need the training data that will collected from 38 cloud data set that available in the internet. You can see from the slide, and it depends on the source of the data, so the reliability will be different. So in this case study, we choose this data set that contains 8,400 pages for training and 9,200 pages for testing, and with the size that we just mentioned before. You can see on at the top of my presentation, this is the ground truth and the 4-band that you use for the classification or segmentation of cloud. And yes, the aim of the training model is to train the model to minimize the losses. The loss is a function of predictor. A function of difference in the prediction and the ground truth you can see on the screen. So we try to minimize the losses, and the result that we have a result of 97% for the training set and 90% from the test sets. Yeah, and the result on the left side. So this is how we integrate, and after the model integrate in OpenDataCube, as we have OpenDataCube data, that's the data available in OpenDataCube, and the model was implemented as a ready analysis model. We have OpenDataCube with a data, we have a coverage of data, and we have anti-area. Now we divide area into small patches, and the patches was injected into the deep learning model for the result. And here we have some suggestions how it works. I go quickly. We have an entire area, you split into patches, and here after going through the model, the deep learning model, we have a cloud and non-cloud pixel here, and we merge together to have an entire scene of cloud and non-cloud. Here's some example of different data cloud segmentation. And here some different areas. Scale cloud segmentation is some result that you can see on the screen. So the aim of this model is to automate reconstruction from cloud contaminated area, to review more than 90% of cloud cover. So that's very good, because optical data is available, but the cloud covering is a big issue. We need to overcome it. So what next? What's the next OpenDataCube? The next application of OpenDataCube that we are working on, the module for single image super resolution that increase the resolution of the satellite data. Especially for the urban application, we really need high resolution data. So for instance, at the top, you can see that the Landsat, we developed algorithm to increase or enhance the resolution. You can see that have a higher resolution. So on the right side is ground truth. That you can see that have some certain level of similarity. We're also looking at another module for cloud filtering and the natural hazard analysis module that work for big data or for large scale. Oh, this is another application of remote sensing from my not from my group, but from my colleagues in my university. That's for the detection of the PV potential in Vietnam, in rooftop of Vietnam. So you can see that's on the left side. They define the DSM at 1 meter resolution from one view tree, and after that we do segmentation of the one view tree image for the roof, and after that they combine. They do manually editing, and after they combine the result over the DSM for the detection of rope does have a PV potential in Vietnam. This application in the south Vietnam because the exposure hour to sun is higher than in the north. Okay, so remote sensing, you can that's I just present some application, but there are many applications of remote sensing in Vietnam because Vietnam has been listed with the country with satellite. We have a natural resource satellite has been launched several years ago and now in operation, and we have a data from this satellite. And for the trusses plan after 2006. We had the Space Technology Institute has been established with the Vietnam Space Center in 2011. The Department of Natural Remote Sensing and Ministry of Natural Resource Environment. That's a reorganization of the Remote Sensing Division to be a department with the more focus on the planning and the strategy of Earth observation in Vietnam. Yes, in summary, we can have the master plan since 2006. We have preliminary infrastructure, we have microsatellites, optical star or hyperspectral, that means some small satellite going to be launched in the near future. We have national research project on space technology. We have a lot of application, education program, and education program and training on space technology. So integration, that is the integration between industry and education and research agencies. And the most important thing that you have a government strategy to 2030 and 2040. That's the most important thing, I think. That the government is paying attention to remote sensing development and with the remote sensing Earth observation. So in Vietnam, you can see that data is not a big issue. Never mind about software and computing platform, but how to effectively use data is big concern in connection with a good strategy and governance. Especially from the coordination from the government and research institute and industry. Okay, now come back to the resource sensing education in Vietnam that I'm working on. You can see that's not only individually developed domain within geographic, but online possible combination and method of program select to show a given problem. That means the highlight and interdisciplinary character of geoinformatics science. That means many departments, many disciplines work together, not only remote sensing itself. So there is no possibility to cover all specialization within one department. Therefore, cooperation with other departments, physically, for some hydrology, geomorphology, and so the regional urban study, land use, land coverage, geography and application thread in the geoinformation content. That means we should work together. That's the department with focus on technical aspect. Research institute on the technical aspect that should work together with the natural resource division and human social regional division. That's to put up the use of remote sensing. Okay, now I can go to the summary of my presentation today. So we have a government strategy to work with remote sensing Earth observation. We have the interconnected disciplines. The geospatial industry is growing pretty fast in my country with a lot of application. I'm not working with the IT department. So with the IT department and some startup business, they have a very good solution with geospatial data. As a educator and a researcher, that we try to bring the benefit of space technologies to education sector at every very beginning stage, primary school. So I have been involved in a project funded by UNESCO to bring the satellite data to primary school. That's the very young student, young people, they are aware what satellite data are. So we call that satellite data is scientifically based evidence, so we can trust on this data. And the most importantly, it connects space to village, local community, and local authority. That means local community, local authority, and scientists should work together to maximize the benefits of remote sensing data. Okay, that's the end of my presentation, and I wish you good health and stay healthy, stay away from the pandemic. Thank you.